Okay, so this one, again, it's in your purple, your linear equations, and I popped it up, and that one was pretty easy. It says to determine the solutions, and it gave you a table. The equation was y equals 5x plus 6, and then it gave you one of those tables with the yes, no bullets on it. You know, you had to mark yes or no. So my first ordered pair they gave me was 7, negative 52. So on these, you just had to substitute the values in. X is 7 and y is negative 52. Not hard at all. So to check this one to make sure if it's a solution, then I would plug in negative 52 where the y is, and I would plug in positive 7 where the x is, and all I'm doing is checking to see if the left side and the right side are the same. Okay, so that's what a solution means, that it makes the equation balanced or makes it true, the left side and the right side are equal. Obviously, this one's not going to be because you can see that I'm going to get a positive number. I don't even have to go any farther. I know it's not going to be true because on the left side I have a negative number, right? Negative 52. And on the right side I'm going to have a positive number. It's going to be positive 41. Yeah, so the answer for this one was no. So you would click the bullet no. Okay? So these are easy enough. They give you 4. And so all they want you to do is test all 4 of those. And you're clicking yes or no. Okay, so that one is simple. The next one, that the reason why I wanted to show you guys this one is there's one that pops up that I think you guys are going to think looks strange. So this is my next example. Woo, that's not right. How do I do that again? Add a page? Is that it? Nope. Okay, let me... I got it. Okay, so my next example is the same thing. It says determine if I have a solution or not. Okay, determine if it's a solution. Oops. And my equation this time is x is equal to negative 5. Y'all haven't seen that yet, okay? X is equal to negative 5. I'm going to write the whole table out this time because I want you to see what it shows. So right here, you've got your ordered pairs, and then right here, you have your yes, no buttons, okay? And these are the ordered pairs that are given to me for this equation. There's my first one, 6, negative 5. Here's my second one. Negative 5, 3. Here's my third one, 1, 4. And here's my last one, negative 5, negative 2. Okay, negative 5, negative 2. So my question is asking me which of these would be solutions. And some people got a little confused on this in my other class, so I want to make sure that you guys understood it. I'm going to go back to this equation. There's my equation. X equals negative 5, right? Okay, so what is the only thing you know to be true?
That the negative 5 and 3.
X has to be negative 5, right? That is the only thing you know to be true. So if your x is not negative 5, then it cannot be one of the solutions. So I go through the x's and I find the ones that are negative 5. And so I see an x of negative 5 here, an x of negative 5 there. I would click yeses on those. And then the other 2 are no's because the x isn't negative 5. The first one, the x is 6. The third one, the x is 1. Okay, so that's all fine and dandy. But what I want you to see now is what would that look like on a graph? What would it look like on a graph? So we're going to take it one more step than what the problem is actually asking for because I want you to be able to connect the dots. What if instead the question said for you to graph x is equal to -5? Well, we know from this table already, if I draw my coordinate plane, we know from this table, here's my x-axis, here's my y-axis. We know 2 points already that fall on that line. The 2 points, we put check marks on them, right? Look at the y's. Well, the y's were random. The y's didn't matter. Because the only thing that I can positively tell you right now is that the x has to be -5. So where is the point -5, 3? Okay, so that point I would go left 5, 1, 2, 3, 4, 5, up 3, 1, 2, 3. Right here, there's -5, 3. And then where's the point -5, -2? I would go left 5, 1, 2, 3, 4, 5, down 2, 1, 2. And then I would draw the line that goes through those 2 points. So what was the name of that line again? X equals -5, right? Okay, look at the line. Look at the line. This line right here is x equals -5. Because every single point that falls on that line has an x of -5. So if I said, well, what about this point right here? Oh, come on. What about that point right there? Well, the x is -5. What about this point right here? Well, the x is -5. What about like a fractional one in the middle? Well, yeah, x would be, stop. Sorry. It's not, it's thinking I want to put a dot, people. There you go. X is -5 right there, okay? X is -5 right here. All of these points, every point that falls on this line, the x would be -5, no matter where you go. So that's a picture of x equals -5. Now, I want you to pay close attention. Y'all look at the x-axis. Y'all see the x-axis? So which way is the x-axis going? It's like this, right? Mm-hmm. Okay, but which way does the line x equals -5 go? Like this. So it's different. And our brains sometimes, when we see x equals -5, our brains want to make it look like the x-axis because we see the x. But that's not how it works. Okay? So I wanted to make sure to point that out to you. I hope that helps. And you guys work today, and I will walk around and help you.